Good morning, students. In the last session, we were discussing about the different digestion that takes place in the human alimentary canal. And two digestion we have dealt with. One is the digestion that takes place in the buccal cavity. The carbohydrate is getting digested in the buccal cavity. Carbohydrate is a polysaccharide and it is being converted by an enzyme called soluble amylase, and the polysaccharide is getting converted into a disaccharide and the monosaccharides. So that is initiated and done in the buccal cavity. And the second one is the stomach digestion. In stomach, protein is undergoing digestion. Now, the protein is getting converted by an enzyme called pepsin, and that pepsin will hydrolyze the protein into polypeptide and peptones. And we also studied another kind of an enzyme which is found only in the infant. It is called the renin. Renin will be acting on the caseinogen in the presence of calcium, and it will convert the caseinogen into a curd, that is calcium casein component. Okay, and that is what we have dealt in the last section. And today we are going to study the digestion that takes place in your small intestine, that is the small intestinal digestion. Small intestinal digestion. So that is what we are going to study today. Okay. Now, when you talk about the small intestine digestion, so this is the part of the small intestine. This is called the duodenum. Now, the duodenum is connected to two different glands. One is, it is connected to the liver and it is connected to the pancreas. Now, the food that is digested in the stomach will be moved into the small intestine called the duodenum. Now the food is there. The final digestion will take place in this duodenum, as well as the fat which is there, or the lipid, that is being converted into fatty acid. It is being converted into fatty acid and the glycerol. So these two things are being produced in the small, will be converted or digested in the small intestine. Not only this fat is getting digested, the another digestion which is all partially digested in various parts of the alimentary canal will be fully completely digested in the duodenum. Okay, so now we'll talk about the liver. Now when you talk about the liver cells, the liver will have the gallbladder in it, and this gallbladder can able to synthesize a salt called bile. Bile is a salt. Okay, so the salt which is there. Now, whatever product is produced in the liver and the pancreas will be poured into this duodenum. So it will enter into the duodenum and it will digest the food substances which is there in the duodenum. Now we are talking about the liver, and the liver cells, that is the liver will have no enzymes at all. When you talk about the liver cannot produce enzymes. There is no enzymes. Okay, so that liver will have only a salt called bile. Very important. Only a salt is present in the liver is the bile. There is no enzymes. Apart from this, this liver will have another two things. That is, it is having the cholesterol will be there. The cholesterol will be presented in the liver. Okay, so that is one of the major component that is there inside. So it is having the cholesterol, as well as it is having some of the phospholipids will be present in this phospholipids. Then it is having two kind of pigments. The pigment is called bilirubin and biliverdin. So these are the two kind of pigments which is there in the bile, and these two pigments are the breakdown products. It is the breakdown products of the hemoglobins. So when the hemoglobin which is there in the RBC, when this is being RBC, when it is being destroyed, because RBC is a graveyard, liver is a graveyard for the RBC. So that means the liver cells will go there and it will the RBC will go to the liver and it will get disintegrated. So when the RBC is being broken down, the hemoglobin pigment also will be broken down, and the broken down product can able to give two pigments, that is the bilirubin and the biliverdin. So these are all the products are there in the liver. Okay, right. Now we'll talk about this bile. Now this bile is a salt, it is not an enzyme. The bile is a salt which is presented in the liver, and this bile will be, see, this bile juice will be entering into the small intestine, okay, in the duodenum, and this bile will be getting activated. When this bile enters inside, already you will have the lipids are present inside. So this bile will get mixed with this lipid. So that mixing one is called the emulsification. Emulsify. So the emulsify means bile salt will be mixing with the lipid, and this bile, now this gets activated. When the bile salt is mixing with the lipid, this is getting activated, and after getting activated, an enzyme called lipase enzyme will be there. Whenever bile is getting mixed with the lipid, the enzyme which is present in there called the lipase enzyme will get activated. Now that lipase enzyme will be converting this lipid into two things, that is the fatty acid as well as the glycerol. So that is the actual the role of the bile. So that is the first stage in the digestion that takes place in the small intestine, where the bile salt gets activated when it is mixing with the lipid, and that activates the lipase enzyme so that it can able to hydrolyze the lipid or fat into fatty acid and glycerol. Okay, so that is the first one. And second one is the pancreases. When you talk about the pancreases can able to have some kind of the lipids. So this is having some varieties of enzymes in it. So that enzyme is called, the first enzyme is called trypsinogen. So this is an inactive enzyme. Trypsinogen is an inactive enzyme. This is one enzyme which is present in the pancreases. Then it is having another enzyme called trypsinogen. This is also inactive enzyme. Then it is having an enzyme called carboxypeptide. Then it is having an enzyme called nuclease enzyme, and all enzymes ends with ACE. Okay. Then it is having an enzyme called pancreatic amylase. Pancreatic amylase is similar to the salivary amylase, and also it is having pancreatic lipase. So the lipase actually similar to this bile, because bile has this can able to activate an enzyme called lipase. Okay, so these are the varieties of enzymes which is present in the pancreases. Now these two enzymes are inactive enzymes, trypsin and imotrypsin, and this trypsin must be activated. So this enzyme called trypsin is activated into trypsinogen is activated into trypsin, is an active form. And the very important one more question is, the trypsinogen is getting activated into trypsin by an enzyme called enterokinase. There was a public one mark question, interior one mark question, which was asked 2 years back. This enzyme enterokinase is a DAS enzyme. So it is a pancreatic enzyme or it is an intestinal enzyme. So that is what the public one mark question. See, this trypsinogen is belong to pancreases, but this enzyme is getting activated by an enzyme called enterokinase, which is belong to the intestine. So that means the enterokinase is an intestinal enzyme. Don't forget it, is an important one mark question. The enterokinase belong to the intestine, that will convert the pancreatic enzyme trypsinogen into trypsin. Okay, right. So that is, now the role of the trypsin is, the trypsin will do two different fundamental roles. Number one, the trypsin can activate. It is activating. So the trypsin can activate the hemotrypsinogen into hemotrypsin. Okay, this is one form of the one function of the trypsin. The trypsin will activate the hemotrypsinogen into trypsin. That is one. Second one, the second major function is the trypsin will hydrolyze. Hydrolyze means break down the proteins into two things. One is the polypeptides as well as the peptone. So these are the products of the digestion of the protein. When protein is broken down in the stomach, and that is being broken down into polypeptide and peptone. Further, it is being digested in the small intestine, and finally it is getting digested into polypeptide, peptone, and finally it comes to the amino acid. So overall, the protein will be converted into amino acids. Okay, right. That's the final stage of the digestion. Now, this is the second role of the trypsin. The first role, as soon as it's getting activated, it will activate the trypsinogen into trypsin. Number one. Second one, this kind of trypsin will hydrolyze the protein into polypeptide and peptone, and then it is converted into amino acid. So that is the role of the trypsin. Now second one, the hemotrypsinogen. The role of the hemotrypsin is, now this also will undergo hydrolyzing, that is breaking down. This breaks down the peptide bonds. I will tell you what is a peptide bond. It will break down the peptide bonds. See, peptide bonds means, if you talk about the structure of the protein, this is the linear straight chain structure of the protein, and protein is made up of amino acids. One protein chain is made up of 20 different amino acids, and all these amino acids are bound by a bond called peptide bonds. It's a bond called peptide bond. Now, protein has many peptide bond like this. So protein is called polypeptide. Don't forget it. Proteins are polypeptide, and carbohydrate is a polysaccharide. Okay, right. Now this kind of hemotrypsinogen will break this kind of bonds in between the amino acid, and especially you should concentrate it. The hemotrypsinogen cannot break down all the peptide bond. It will break down only some specific amino acids, not all the 20. Some specific amino acids like trypsin, hemotrypsin, that we will study later, right? Okay, so now this kind of a specific amino acid bonds only will be broken down, and after broken down this peptide bond, the hemotrypsinogen will be associated with a kind of a specific amino acid breaking, right? So now the hemotrypsinogen finally break down only a specific, not all. So it is the specific amino acids, or AMs amino acid broken down. Okay, so that is the role of the hemotrypsin. Okay, carboxypeptide is also related to the protein will have the peptide bonds, all this. So this is also having the same role as similar to the hemotrypsin. Okay, the nucleus I will talk to you later. Then we talk about the pancreatic amylase. Very easy, very simple. The role which is played by the pancreatic amylase and the role that is played by the salivary amylase, both are same. That is, this pancreatic amylase also hydrolyzes or break down the polysaccharide called starch, and the starch is converted, is a polysaccharide. It is converted into disaccharide, then it is converted into monosaccharide. You know the different disaccharides, you know, the disaccharides, you will have 3 disaccharides. One is called the, you should remember all this. So maltose, then you will have the sucrose, then you will have the sucrose, you will have the lactose. So these are the 3 disaccharides. Okay, so now this is getting broken down, and when the monosaccharides, now the maltose, when it is broken down, you will have glucose plus glucose. So it's a monosaccharide. Glucose is a monosaccharide. Okay, so when you break down the sucrose, it will have glucose plus fructose. All this we will study later. Then when the lactose is broken down, you will have glucose plus galactose. So these are the end product, monosaccharides. So you should know the examples. Starch and carbohydrates are polysaccharide, disaccharide, maltose, sucrose and lactose, and monosaccharide, glucose plus glucose, glucose plus fructose, and glucose plus galactose. Okay, so these are the end product of the digestion. So ultimately, when the protein getting digested, it forms amino acid. When the lipid getting hydrolyzed, it forms free fatty acid and glycerol. Okay, so these are all the micromolecules. That is what in the beginning we studied. Digestion is conversion of macromolecules into micromolecules. So lipid or fat is a macro, converted into micromolecules like fatty acid, glycerol. Similarly, protein is a macromolecule, converted into amino acid. Carbohydrate is a macromolecule, starch, converted into micromolecules like monosaccharides. Okay, so that is the actual content. Now you should have a question, sir. Already on digestion, start digestion is done there in the mouth. Then why it is continuing the small intestine? Is partially only it is digested in the, so that is what the very beginning I told you. Initiation is done in the buccal cavity mouth and the final digestion is done in the duodenum. So the rest of the all the digestion, one part is done in the mouth, rest of the digestion, everything is done in the duodenum. So the overall product. Clear? Right. Next one, the lipase is same. Pancreatic lipase is very much similar to the bile salt that is activated. So the lipase will get activated whenever the bile salt from the liver will mixes or emulsify or mixes with a lipid which is there or fat which is there in the duodenum, and the lipase is activated. Same lipase can able to divide or broken down into fatty acid and glycerol. Clear? Right. Now the last part of the small intestine is, see, liver has played its own role, pancreas has played its own role. The last one is the intestine itself now is playing a role. That is what the intestinal juices. So we have studied pancreases, liver, we have studied the pancreases, and the last one is the intestinal juices. Intestinal juice, intestinal digestion. Okay, in intestine we have some enzymes. Okay, now these enzymes are some nucleus enzyme is there. That is also I will talk when I talk about the nucleases and intestinal enzymes. Okay, in intestine we will have some kind of a glands called known as gland, as well as some secretions. Now the enzymes are secreted in the intestine. Very important, very important. Now the intestinal enzymes are the maltase enzyme, then sucrase, anything that ends with ase is called enzyme, then lactase enzyme. Apart from that, you will have another two enzymes that is called dipeptidase and the lipases. Okay, now you can able to understand where the lipase enzyme is. See, we have studied bile belong to the liver and the lipid is there in the duodenum. This is mixing. When it's mixing, the lipase is activated. So the question is where the lipases belong to. So the lipase enzyme belong to liver, pancreas or intestine. It is very clear lipase enzyme is belong to the intestinal juice. So it is a very important public 1 mark question. Especially enterokinesis also belong to the intestinal enzyme. When they ask you to write intestinal enzyme, please write enterokinesis also along with that. Okay, the role you know, it is getting converted and it is converting the trypsinose into trypsin. Okay, right. Now I just completed with this. Now see the role of maltose, sucrose, lactose. Very clear, the maltose enzyme will convert. See, the maltose is a product, disaccharide. The maltose is converted into glucose plus glucose by the enzyme called maltase. Clear? Same, sucrose converted to glucose plus fructose by an enzyme called sucrase. Lactose getting converted into glucose plus galactose by an enzyme called lactase. So you should write like this. That is maltose, enzyme called maltase getting converted into glucose plus glucose. Similarly, sucrase, glucose plus fructose. Yeah, then lactase, glucose plus galactose. So likewise you write. Then now see. Here one product that you have to understand, protein is getting converted to peptide and peptone. Up to that it stops. It stops in the stomach as well as in the first part of the digestion, the duodenum. The final digestion is now these products has to get converted into amino acid. So you will have an enzyme called dipeptidase. So here the dipeptidase enzyme is converting this peptide and peptone into amino acid. Don't forget it. So this is the product of the dipeptide. So dipeptide will convert that is di and tripeptide will convert into amino acid. Okay, so that is this is an enzyme. So dipeptase is an enzyme. So the product here, this is the peptide and peptone. Instead of that, you can also remember it is a di or tripeptides. peptides. So the di and tripeptides are converted by the enzyme called dipeptidase into amino acid. Clear? So that much you are understood. Lipase also you have clearly understood. Now only one enzyme is left. That is called the nuclease. Okay. Now the nuclease enzyme, actually you will have the two nuclease enzymes are there. One is the nucleosidase and nucleotidase, and very important one, the nucleotide and nucleoside. So don't forget it. You have to write two enzymes simultaneously. The one is called the nucleotide and the nucleosides belong to nucleate. First one is called the nucleotides and second one is called the nucleoside. Okay, remember first one is type and second one is side. Okay, so now the nucleotide will be getting converted into another products. Now this is also done by enzyme called nucleotidase enzyme, and this is nucleosidase enzyme. Okay, now the nucleotide will be getting converted into two things. One is called the nucleoside and phosphoric acid. This is nucleoside plus phosphoric acid. Okay, you will be there in the book afterwards, you can verify. The nucleotide will be converted into nucleoside and phosphoric acid by an enzyme called nucleotidase. Then nucleoside will be converted by an enzyme called nucleosidase into the final product called sugar. Sugar is the final product plus nitrogenous base. Nitrogenous base. So this is the final product by using some enzymes called nucleotides. So all this are done in the the maltose, sucrose, lactose. So that is very clear, the end products. So here the monosaccharides and here the amino acid, that is from the di and tripeptide, and here the nucleotide and nucleosides are all done in the small intestine. Okay, then after all this, these products are all, that means the final products you supposed to remember, all these are final products. See, the amino acid is a micromolecule and monosaccharides is a micromolecule from the polysaccharide, and the end product like this one, the sugar and the nitrogenous base. Okay, so that is the third product, and the lipids, fatty acid and glycerol, all these are micromolecules. Now all these are done in the small part of the intestine, and every product which I have circled in red color will be absorbed and sent to the different part of the body. Especially these products are all stored in the liver and the muscles, and whenever your body is required of energy, these kind of products are liberated and your body burns this energy for your survival. Clear? Right. So that is what the small intestine digestion is. In the next classes, we are going to study about the absorption of these materials, and after absorbing, we are going to study about some kind of a disorders that is related to your digestion, and with that your 20% gets completed successfully. Clear? Right. In the next video, I will catch you up with disorders that is related to your small intestine. Clear? Right. Thank you.